Hello everybody, welcome back to my channel, and today I'll be doing my first teaching video, and in this video I'll only be doing a little revision for our KSSM syllabus chemistry chapter 4 form 4. For chapter 4 we learn about periodic table. So it will be easy because I don't really go in details, but I'll give you what you need to know before SPM. So without further ado, let's go right now. Okay, so let me share my screen. Okay, so to know the periodic table in our KSSM syllabus, we only learn 3 groups. Okay, so how do you differentiate? Okay, we go to basic first. Okay, let me get my pen. Okay, so group means this one, the one that goes down. Sorry, take a little bit. The one that goes down, you see it? This is what we mean by group. So like I'm teaching you how to look at periodic table. So this is group 1 means this is group 2. This is group 3, group 4, and group 13, group 14, group 15, and whatsoever. This is what you mean by groups. That means the vertical column means from up going to down. It is the group. Okay, so how about period? Of a periodic table, we got 2 things here. We got group and period. So period will be horizontally column. The horizontal column means it will be like this, like this, like this, like this, from left to the right. Okay, from left to the right. So this is what we mean by period. So this one will be your period 1. Here will be your period 1, period 2, period 3, and period 4. Okay, so this is the first thing I need to understand first. So what we mean by group and period, this is how you see it. Okay, so let me remove everything. Okay, I want to be faster. Okay, so now you know how to look at groups and also periods. So now we look at something that's very basic that everybody needs to know. Okay, so in a symbol, okay, so we have like in an element, sorry, in an element, we have symbol, we have the name, symbol, name, and also your atomic number and average atomic number. But in your textbook, we don't see something like this, which means you'll probably be seeing, okay, all right. You'll probably be seeing relative, what happened to my marker? Okay, you'll be seeing relative atomic mass, okay? So relative atomic mass, okay, I don't think we really mentioned this thing, but it's the same thing like relative atomic mass. And relative atomic mass is actually equals to your nucleon number. Okay, so what it means by relative atomic mass or nucleon number, so this is actually our the mass, okay, the mass, the the total mass, okay, you can say that way. So what is the number here then? The atomic number. The atomic number, we'll say like proton number in this case, okay? Proton number. So my teacher teach me is, okay, so you see there's a bigger number, right? That will be your atomic mass. Or nuclear, we say nuclear number, there will be your nuclear number, relative atomic mass, okay? The smaller one, 78, of course, smaller, all right? So it will be your proton number. So in this, from here, we can see that the smaller number and also a bigger number, the smaller one is your proton number, Sorry, it's not a proton, it's a proton number. And the bigger number will be your nuclear number or our so-called relative atomic mass. It's the same thing, okay? Then the symbol is just represent like, calcium is C, like that, okay? Copper is Cu, that's it. And the name will just be the name lah, normal as it is. Okay, so now you know how to look at it already, right? So we go to next step. So we go to harder bit. Okay, so now we learn something more details. Okay, so we also learn about, atoms, right? Every element here is an atom. So what is atom? Okay, atom, when you saw the word atom, right? In exam, it means your proton number your proton number is equals to your electron number. That means how many your proton is equals to how many electrons. If you have 5 proton, that means you have 5 electrons. Atoms are not reactive. That means they are just element by themselves. They are atoms. They do not, they do not carry any charge. Okay. Atom, they do not carry a charge. So that's why their proton number and electrons are the same. Electron number are the same. First thing you need to know. Another thing is we also learn about electron shell, remember? Electron shell, where by looking at the proton number, we try to write like how many shell and how many valence electron, all that, right? So we gotta do this right now. So let me find. Okay, let's say it's sodium, right? Sodium, we use sodium. So now let me ask you again, which one has larger number? The bottom one. So this is your neutron number. The smaller one will be your proton number. So remember I said what? All the elements in periodic table, they are atom, right? So when they're atom, means the proton number, electron number is the same. So agree or not, when I have proton number is 11, that means my electron number also 11. That means I have 11 what? 11 electrons. So how do you present it? So we have a ways to present it. So by doing something like this, what dot, what dot, what dot, remember? This is how we present it. So 11, so okay. The first thing you need to know is the first shell, okay, I think it's a little bit too thick. Wait, a little bit. Okay. So the first shell, right, the maximum electron is only 2. The second shell, the maximum electron is 8. The third shell, the maximum electron is also 8. Let's say if there is fourth one, the maximum electron will also be 8. 8 or 2 jialat. Wait. Sorry, I think it's 2. Yeah, 2. Okay, it's 2. So you have meaning, right? The first shell, let's say let's say I have 8 electrons. So the first shell will only be 2, and then the other 6 will be here. You get what I mean? Because here is already full, understand? Okay. So now we go back to the question and we try to do lah. Okay, so the question here says that there's 11 of your electrons. So the first shell confirm only maximum 2, so you put 2, and then 8, 9, 10, 11, one more. So will be 1 here. That's it. Then this is the electron arrangement for your sodium. Electron arrangements means like how your first shell you put how many electrons, second shell how many, and then third and so on. Then how do you draw it? Okay, then I draw it for you also. Let me show you. So sodium, right? Sodium, I just write Na. Depends if they want atomic, they write like this. So sodium in the middle, the first shell, this is what I mean by first shell. Just now that one is just writing out. This will be how I draw it. First shell, you have maximum only 2. Is it? Only 2. So if it's only 2, then you draw 2 electrons inside lah. So 1 and 2. And the third shell, you are filled with 8 full of it, right? So draw another shell. The second shell will be 1, 2. My teacher teach me is you always draw clockwise. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. That's it. And then the third shell, draw another shell. Draw my drawing is a bit ugly, and then draw 1. That's it. Then this will be how you draw it out in exam. Okay. So this is all that you need to know for this. These are very basic. So let's say if it's potassium, rubidium, you just do the same thing. You try to do it. Okay. That's all. So now, in our KSSM syllabus, actually we only learn 3 groups, as I said. What is it? Which group is it? Okay. We only learn group 1. Wait. We only learn group 1. You can see my highlight, right? Group 1 and group 17 and also group 18. Okay, also group 18. These are the only 3 groups that we learn. Then what do we learn in it? We learn about the reactivity, the application and those kind of stuff. And the melting point, boiling point, those kind of stuff. Okay, so now we go look at it. Oh yeah, I forgot to explain. Sorry. Uh, okay. Another thing is here. You see, right? There is uh there is first, second, and third shell. Agree or not? So when there is three shell, one, two, and three, that means your period will be three. Okay, I forgot to explain these very important things. Group one means you got one valence electron, and this is your valence electron. Valence electrons means the last electron, the last electron. Okay, the last electron here is one. Let's say, for example, if it's two here, that means your valence electron will be two. Then you will be drawing another X there. If my valence electron is three, that means I have three valence electron. That means I'll be drawing another X here because that represents electrons. Okay. So the last one is your valence electron, and your valence electron is your group. So group one means you got one valence electron. Okay. So that's why the answer is one. Agree or not? So that means from hydrogen to my francium, I will end up with one valence electron. This is theory. Okay, and then what does it have to be do with the period? Period means how many valence electron, how many electron shell are there? So if it's one, that means you only got one. That means one, oh, that's it. Okay, sorry, two, right? No. Sorry, one. Okay, and if it's two, that means you will end up with something like this. So it's actually quite simple, ma. You see three, right? So three proton means three electron. So the first shell will put two, the second shell you put one. So add it up, you get three. That's how you get it, right? So it makes sense. There's two shell here. So period stands for two shell. Okay, we do another one. Okay, 11, sodium, right? You see three shell, one, two, three. Period three. So period three means is actually equals to your shell, electron shell. How many electron shell? If period three means three electron shell. If period four means four electron shell. Five means five electron shell. Group one means you have two valence electron. Group 18 means you have eight valence electron. Group 17 means you have seven valence electron. Or it's not 17 or seven. Okay, this is the important things that I need to know. Next, we go to this we start to study the group lah. Okay, so group one is actually alkali metal. Okay, alkali metal, which is the at the group one the most left hand side here. Okay, if you can see, this is my group one. Okay, and this is my group 17, and this is my group 18. Okay, so group one, what do we learn? So we have lithium, calcium, aluminium. Okay, wait. No. This not. Alamak. Lithium. Wait. Sorry. I'm so sorry. Where's my group one again? Group 18 first of. Here, group one. Okay, group one, we have lithium, sodium, potassium, rubidium, uh, calcium, is it? And francium. So, how to remember? There's a way. It's called, did you teach me one? It's Lina, Nak, Pelua, Rumah, Chari, Francis. Okay, this is the way I remember. So, talking about group one, right? The reactivity of it, that means like every metal got reactivity. The reactivity between them is actually different. So the reactivity will be increases down the group. You know why? Let me show you. Reactivity increases. Okay, why? Okay, so it's actually very simple. Here, the concept is like this. Okay. Remember I said it always ends up with one valence electron because it's group one ma. So okay, so you see, when I have one valence electron, is it easier for me to receive or donate. It's easier for me to donate, right? Instead of receive, because you see, I got, wait, let me draw it out. So this is the electron arrangement. So I have one left. Okay, I have one left. Is it easier for me to donate? It is, right? So when I donate, it will become 2.8, right? Then it become ions. But you see, if I am to receive, that means I need to receive another 7 more, which is not easy to do. So that's why when the reactivity going down, it will increase, because you try to see when my, okay, we go back to periodic table here. Okay, so when going down, right, if you realize it, the electron shell actually increases. So you see, the electron shell from here would, the size, okay? The size like this, from like this to like this, becoming bigger, bigger, and bigger. Oh my God. And bigger, right? So when it turns out bigger, did you realize or not? The valence electron is getting further with your atom. You realize that? At first, it's actually very close, you see? Your valence electron is very close. But when it goes down, it becomes further. The valence electron is further from a nucleus. And then the force of attraction between them becomes weaker. So when it becomes weaker, it is easier for it to donate the electron, to release the electron, right? So when it is more easier for them to lose electrons. All right. So that's why it's more reactive, because you see, what it means by reactivity means in this case, it is easier, they are supposed to lose electron, right? So now when going down to the group, the size increases, so that the electrons, the valence electrons and the nucleus, the distance between them become further. So it is easier for them to donate compared to the one on the top. Because the one on the top, they are so close, the force of attraction between the nucleus and the electron is so strong that it is very hard for them to lose the electron. But the lower part, the electrons shell has many of it. So it is very hard for, it's very easy for it to donate electrons. You can lose it anytime, because the force of attraction between the nucleus and the valence electron is very, very far. Understand? That's why the reactivity increases down the group, because the shell increases, the valence electron far, and the force of attraction weak, is more easier to donate. That's for group 1. Okay, for group, okay, so this is it. This is what I want to explain. Again, I draw it again. Okay, it will be like this. Like this. Just a concept. I didn't really, because takkan I go calculate one by one. It's full time taking. And I cannot use my tuition note lah, actually. So yeah, you see, valence electron, you see, very close. Not so easier to donate. So the reactivity, not so good. Not reactive. But here you see, very, very far from nucleus. So it is more easier to donate. Their purpose is donate, right? Release the electrons. So confirm this one, the reactivity is higher than top first one. So meaning, right, lithium is the most not reactive in group 1, and francium is the most reactive in group 1. Okay. And then for lithium, for alkali metal, right, we have a few application here. Lor. So lithium is used in our battery, like our phone battery, all the battery, we use lithium. Sodium, we use it in light, in our street lights. Potassium, we use it in fertilizer. And there's still like other application. The extra one for example, uh, baking soda, we use sodium as well, sodium, uh, salts, sodium, what else? Let me see. Uh, Calcium is, oh yeah, calcium we can use in photoelectric cell. That means, our photoelectric cell, photoelectric cell will be using calcium as well. And also, banana, we have potassium. Banana, we have potassium in it. Potassium. Potassium. Okay, so these are just extra lah that I have in my book. And now we go to group 17, group 18. So group 18, remember, very simple. Group 18, so it's a joke lah. Like, how I remember is group 18, I call my friend group 18, you know why? Because my friend is very steady, you know. Those, you know, you kacau them, and then they don't get angry easily one. They're very steady one. No matter what you do to them, you slap their face or take off their underwear, they are very steady. Those are group 18. Because why? Group 18 are chemically inert. Chemically inert means chemically inert, okay. Sorry. Chemically inert means they are not reactive. Chemically inert means they are not reactive. Meaning, right, they are already stable. What do I mean by stable? Stable means, okay, just now, right, you see, there's one valence electron, right? Okay, so it's not considered as a stable thing. Because why? You can lose it, right? Because their main purpose is to lose electrons, ma. So it's not stable. But in group 18 is different. Remember I told you or not? Group 18. 8 means, group 18 means got 8 valence electrons. So you see, 2.8.8 or 2.8 or 2.8 point, 2 point, sorry, like any other example? Yeah, no more. This case, you see, did you realize something or not? They all end with 8. That means my first valence electron, my first shell, I got 2 electrons full already. Second shell, I have 8 of them. So it's full. You don't get like something like 2 valence electron or 3 valence electron or 4 valence. You don't get something like this. You only get full. That means, you see, my third shell I fill with 8. Okay, and then my fourth shell I fill with another 8. Something like this. This is the concept. It's full. It won't end up like 4, 5, 6. No, it's full. Okay. So, but anyway, I think, yeah, the fourth shell is 2. Maximum is 2. The fourth shell, so shouldn't have 8. So, rub it off. The fourth shell only have to remember I said earlier, the fourth shell only got 2. Like that, oh. Okay. So when they are full, right, you see, their last shell is full, so they don't get any valence electron, so they are not reactive. And yeah, that's all. Any other thing I can okay, so they are not reactive, so no going up or no going down. Okay, no. That's it. And the application for group 18, okay, group 18, how to remember? So the way to remember is hantu hantu wait. Yeah, correct. Hantu na X-ray. Okay. The last one you can just ignore, I think. So hantu na X-ray. This is how I remember. So hantu means helium. Okay. N means neon gas, and argon. A means argon. K means krypton. X means xenon, and ray means radon. Okay, so how do you use them? So actually, helium we use in balloon, everybody knows, and also you know, when people who go diving, they have that oxygen tank, but inside, right, actually got 80% hydrogen, and then another 20% is actually just your oxygen. Because because helium, not hydrogen, sorry, helium. 80% is your helium, because helium, they they there's less soluble than nitrogen in the blood. Okay, so that's it. And then for neon, it's actually very fun. Neon, you know those when you go streets, right? You go to street, you saw those colorful lamp lights. Those are actually made of neon gas. Okay, the gas inside the light lah. Argon, argon, argon we use in light bulb, and yeah, light bulb we use in light bulb. Argon we use in light bulb, and then krypton. Yeah, no more other example I can give. As simple as that, just know a little bit of the application. That's it. And yeah, actually very fast already. Okay, so now we done group 18. Just remember it's chemically inert. It doesn't release, or it doesn't donate or receive electrons. No, okay, because it's chemically inert. Now we go to group 17. Group 17 will be, mana eh? Yeah, here. Group 17. So group 17 is reactive. How do you know group 17 is reactive? Okay, you look at the group first. Group 17 means got how many valence electron? 7. Okay, just now group 18, 8 valence electron. Group 1 valence electron. 17, 7 valence electron. So, okay. So in group 17, we got fluorine, chlorine, bromine, iodine, astatine, right? And then the last one, I wasn't sure. So we have all this stuff. Okay. Last one is what? Tennessine. Yeah, tennessine. Okay. Usually, for me, right, I don't really remember the last one. But the most is these three. In question, we'll encounter these three the most. Okay, so group 17, 7 valence electron. Okay, let me ask you one thing. Theoretically, let me draw it out. Okay, so that means it left 1, 2, 3, 4, 5, 6, 7. It left 7 valence electron. Let me ask you first. You always ask yourself like that. Okay. I give you one concept first. Okay, group 17 is a very reactive gas. Group 17 is your gas. What gas is it? It's called halogen. Halogen gas. Just now that one is Nobel gas. Okay, forgot to mention. Group 18 is your Nobel gas. Nobel gas. Okay. And then come back to group 17. Okay. So halogen gas, let me tell first, it is very reactive. And the reactivity decreases down the group. Remember just now group 1, right? The reactivity increases when it goes down to the group, right? But in this case, for halogen gas group 17, the reactivity increases when you go up. Go up. Okay. Okay. Do you remember fluorine and chlorine? This one I just teach you how to remember. So chlorine and fluorine, they are deadly dangerous. That's why in your science lab, right? In your school science lab, you won't be able to see these two things one. Because if you breathe in the gas, you can terus die. Instantly die lah. Okay. So fluorine, I remember I don't remember what war is it, but somebody discovered fluorine. Is it fluorine or chlorine? They use this gas to kill all the army. Okay. During the war during peperangan lah. So these two gas is actually quite deadly one. Okay, quite deadly. So now you know that okay, they are very reactive because they are deadly. Remember the story I told you, right? So these two are the deadliest. So when they go down, the reactivity decreases, because these two are so strong, right? I hope I don't confuse you when I say this, but this is how I remember. You see, fluorine and chlorine can kill people. That means they are very reactive. So when they are very reactive, so when it goes down, right, of course, those elements at the bottom will be less reactive. Okay. Then next, since you know that group 17 is reactive, okay, so you know that it has to do with something with release or gain electron, receive electron, right? So just now remember I told you group 1 metal, they are considered as reactive metal. So for group 1, they lost electron, right? Now, let me ask you, since you know that group 17 is reactive, then is it receive or release electron? You tell me. Okay, in this case, 2.8.7. Okay. What do you think? Your valence electron is 7. So do you think it is easier to gain 1 or to lose 1? It's easier to gain 1, right? So when you gain 1, it becomes 2.8.8. So it becomes, okay, we also learned this thing. I also forget to mention because I actually don't do any preparation. So here will be your octet. Sorry, octet electron arrangement. Okay. Okay. So how do you know what is octet? Okay, octet means your valence electron is 8. So your valence electron is 8. That means this one is octet electron arrangement. If your valence electron is 2, that means this is duplet electron arrangement. Understand? So in this case, when you gain one electron, you get it, right? So you achieve what? You achieve in exam, you have to write achieve. So it achieve octet electron arrangement. Let's say this one is 2. Then what do? You say it achieve duplet electron arrangement. Done. This is how exam will ask lah. Okay. So you see, now you know, okay, group 17, because group 17, all valence electron is 7. So now they are more easier to gain one. Their purpose is to gain one electron and then become to achieve in this case octet electron arrangement, right? Okay, because they are 8 ma. Okay, then you see why the reactivity increases up the group. There is actually an explanation. So we have to look back to the number. So why okay, there. Just to show you that here this is group 17 and group 18 is at the right hand side. Okay, so group 18, it is easier for them to receive, right? So I agak only it's not accurate one I draw their electron shell for you. So as you can see, right, the size increases also. Okay, the size increases. So when the size increases, now let's put our valence electron and see. It's actually 7 of them. So okay lah, you know lah Okay, because I'm gonna end it fast the Zoom. Okay, so here we need to gain one. So let me ask you which one is easy to gain? You try to think which one is easy to gain? We only look at just look at this part. Oh shit, sorry. Alamak. Okay, we only look at the toppest one. Why I cannot? Okay, we only look at the toppest one and the lowest one. Okay, so let me ask you which one is more easier to gain one electron into the last electron shell to achieve octet electron arrangement? So how do we know? We have to look at the force of attraction between them. So you see, the distance between the first one and the last one, which one do you think is longer? The last one, right? Because the distance of electron and the nucleus for the last one is the furthest, right? However, for the first one is the closest. So that means the force of attraction between them, the van der Waals force we so called is strong. The last one, the force of attraction between nucleus and the electron is weak, right? So you think stronger force is easier to attract electron or weaker force? Of course, stronger force ma. So here, the stronger force means it's easier for it to receive one electron. However, because the last one, the distance between electron and nucleus is so far that the force is weak, it is harder for them to receive the electron. So the it's harder for them to gain one valence electron. Hence, remember their purpose here is to gain electron, right? To achieve octet electron arrangement. So in this case, this is why here is more reactive than the bottom. So that's why the reactivity increases up the group, because from the upper part, the size is smaller. The force of attraction is stronger. It is easier to pull the electron. When you go down to the group, the size increases, the distance between electron and nucleus further, the force also weaker, harder to attract. That's the explanation. I already go my max already. I didn't do any preparation, actually my own account was deleted. So this is my basically first video. And yes, yeah, application for group 17 will be very good. Takkan you right? Go kill people, right? Use the gas and go kill people. No, right? No such thing, ma. So the application of them is here lor. Chlorine we use in bleaching agent. Bleach, we have the the one that we 就是 our baju one, the bleaching agent. We use bleach to clean our shirt. Okay, and then bromine as a substance in fire extinguisher. No lah, joking only. You don't go and wash your shirt. Bleaching agent is to clean like the toilet, toilet. That's all. And then bromine is used in your fire extinguisher. Iodine is disinfectant. So, if you are BSMM in your school, then you be taking like disinfectant, right? So you saw the iodine word there one. Iodine is always there for disinfectant because iodine, it is for there to disinfect one. Okay, to kill bacteria. And then other more will be what there's some extra here. Let me check. Extra. Yeah, extra. Oh yeah, your toothpaste, you'll be using fluorine. Will be different lah. Of course, takkan you say everything of chlorine, then it will be dangerous. You see, like chlorine is a very dangerous gas, right? But if you mix with sodium, then it will be different. Hey, wait. Yeah, okay. Sodium, when you mix chlorine, when you mix sodium, it will be very different. Because why? Because NaCl is what? Table salt. Then you can eat it already and you're eating it all the time. Okay. And then yeah, oh shit. Chlorine. I didn't think of this. Chlorine, right? You use as uh to kill bacteria in the swimming pool as a disinfectant also. To kill all the germs in water, yes, chlorine. Okay. And then chlorine in bleach uh is to white your clothes lah. Is to white your clothes lah. Okay. Yep. That's it. And bromine also will be used in pesticide also. Pesticide. Okay. So that's all for here. And I think presenting like this is just a very simple concept. But doing question is really the main thing lah. Because for me, yes, my teacher is very good at teaching, but I do question to understand more. So next video, I'll be doing a few questions, a go through. Then I show you how I do the question, how I get those keywords, and then you follow me. Okay? Because that's the most important part. This is just understanding base. Okay, so thank you for watching my video, and sorry if I make any mistakes because like I seriously didn't prepare anything this time, but I really wanted to make my first video before 2023. Today is the last day, and I'm also having SPM soon. So, bye bye. Hope you like it.